Welcome to our fourth webinar in the series of requirements engineering. In this one, it's going to be about requirements validation. My name is Jose Muñoz, and I'm currently working at Visual Requirements and Visual Solutions, as a consultant. In the past years, I have been gathering experience in different projects as a system analyst, system engineer, and also conducting some trainings about the requirements, also working as a business analyst. We'll be sharing in this webinar those experience and good practices that I have been gathering when working with requirements. Today is our fourth session, our fourth webinars in the series about requirements engineering. We will be recapping those concepts already learning in the first three webinars, which were about requirements analysis, requirements elicitation, and requirements specification. After that, we will be moving forward and focusing on today's activities or on today's activity in the requirements engineering series, which is going to be the requirements validation. Okay. Before starting, please allow me to explain a bit about the GoToWebinar interface to all of you. First of all the attendees are in listening only mode. They are all mute in order to avoid noises in the line. However, there is a questioning tab that you can use in the right part of your screen in the GoToWebinar interface, and any question that you post in there will be answered at the end of the webinar. We will have some time for questions and answer, and I will be answering any question that you may have at the end of the webinar. Additionally, we are recording this webinar in order to post it afterward in the different social medias, in the different internet medias, YouTube, Vimeo, and so on and so on. So you will have also a link once it's ready with this recording. Also, a third point that I want to just mention before starting with the webinar, it's the title itself. As you can see in the invitation, it says requirements management, but here in the slides it says requirement engineering. We are using the requirements management title from the invitation because probably requirements management is more common and it's more popular, let's say, when talking about requirements. But in fact, the thing is that all the activities that we are describing in this webinar series are about the requirements engineering, not just the requirement management. Requirements management is just a part in the requirements engineering. Okay, so that's why those two different titles, requirement engineering and requirements management. Okay, so let's move forward and let's start with the webinar. First of all, the agenda for today is going to be this one. We will have a short introduction about Visual Solution, our company. It's going to be very quick, just 1-2 slides. And after that, we will be moving to just recapping the concept that we have learned already, the lessons we have learned in previous webinars in this series, just as I was mentioning, about the requirements analysis, about the requirements elicitation or gathering, and also about the requirement specification or documentation. Once that have been recapped, we will be starting with our main topic on today's webinar, which is going to be the requirements validation. Okay, we will be focusing on validation. We will be describing the difference between validation and verification. What are those two concepts which are usually linked together and are really important, both of them. And also we will be just mentioning some of the most common technique for performing the validation process. Okay. We will have also at the end of that, sometimes at the end of the webinar, for summarizing all the things that we have mentioned, all the things that we have learned, and finally just some time for question and answer. Just as I said a moment ago, remember that you can use the GoToWebinar interface for posting any question that may arise during the webinar itself or just at the end of the webinar, doesn't matter. When it arises, I will be answering them at the end of the webinar. So we are ready for starting, and let's just jump to the first thing in the agenda, which is going to be just introducing a bit about requirements, about our company, the requirements company Visual Solution. Okay. Well, Visual Solution is a company, as I was saying, specialized in requirement engineering for both system engineering and software engineering companies. Okay, at the end, requirements are everywhere. They are there when you are building software, but they are there also when you are building a system. You are building an airplane, you're building chips, you are building mobile phones, whatever. Requirements are there. So we focus on both requirements for the software world and for the system world. Okay. We are manufacturers and distributors of Visual Requirement, which is our leading requirement solution. It's a tool specialized in the requirements engineering process and also in the requirements management. Okay. Our headquarters are located in San Francisco in the United States, and we have got also offices in the UK, in Spain, and in Germany. We are ISO SPI certified and also IREP certified, of course, as a requirements company, we must be. One interesting thing about this webinar is that our company is manufacturer and distributors of our requirements tool, Visual Requirement, but I haven't discussed anything about tools so far, anything about tools yet in this webinar series. Well, as I mentioned in previous chapters, the reason for that is that I want to focus on the theory and practical aspect also of the requirements engineering process, but from a non-tool point of view, I want to focus on all the activities or the process around the requirements engineering without mentioning any tool yet. Eventually, not in this webinar, but in a future webinar, I will be just showing how a tool, specifically how Visual Requirement, is going to help us covering all those activities and especially the requirements management. But that is going to be in a future webinar. Today, I'm going to just focus on the activities and processes regarding the requirements validation, but let's say that in a tool-independent way. Okay. And with that being said, let's just remember what we have learned already in previous chapters about the requirement engineering. Well, the first things that we have stated in previous webinars is that it's a definition or just an explanation for requirements engineering. Well, the requirement engineering, as we have said, is just a set of activities that concern with identifying and communicating the purpose of a system or software. Remember that we always say both system and software, and the contents in which it will be used. Therefore, requirement engineering acts as a bridge between the real-world needs of users, customers, stakeholders, and any other constituents affected by a software or system, and the capabilities and opportunities afforded by the software or system intense technologies. Okay, so that's going to be a definition for the requirements engineering. We have also said that requirements engineering it's based on 4 main activities, and the word activities is important in here because we are always focusing in saying activity instead of stages, because they are not stages. We are not going to do the first one and then the second one. We are going to be moving forward and backward from this activity, so that's why we are using the word activities instead of stages. Those activities are going to be the elicitation or gathering, the analysis, the documentation or specification, and the validation. Okay, we have focused already on the first 3 activities, the elicitation, which is about gathering the requirements, about capturing those requirements from the different stakeholder users and so on. We are also mentioned about the analysis, which is basically about understanding those requirements. We have gathered the requirement, we have to understand those requirements. And we have also focused in the documentation or specification. We have gathered the requirement, we have analysis, we have analyzed those requirements. So now we have to specify them in a more proper way, in a more formal way on a document. Okay. Once again, remember that they are activities that we are going to be doing them mix. All of them, they are going to be together. At the same time, we are gathering the requirement, we are eliciting requirements, we are also analyzing them, we are just checking with the user that we have understand those requirements, we are negotiating those requirements, and also when we start documenting those requirements, we are going back to the user, just asking some questions, gathering more requirements. At the same time, we are specifying and also analyzing those requirements. So everything is mixed together. Okay. So regarding those three activities, the first one, the elicitation, okay, which is about gathering the requirements, about capturing, about getting the requirements from their source. Usually elicitation is just problem-oriented but not solution-oriented. Okay, that's true for the elicitation and for most of the requirement things. Of course, we will eventually get into the solution at the end. The different requirements, well, the high-level requirements, the user requirements that we will be gathering are about the problem, describing the problem, and at the end we will have some system requirement which will describe a high-level description, of course, of a proposed solution. We are not going to enter into the detail, into the how, but we will be just focusing mainly in the problem. Also with the low-level requirement, also in the solution, but it's mainly about the problem, of course. The elicitation is about discovering the boundaries of the system, of the right system to build. Okay, that's also really important when gathering the requirement. We have to understand what the system is going to do, what is going to be inside the system, and what is not going to be there. Elicitation is also about collaborative work between the stakeholder and requirements engineer. Remember the word stakeholder, it's really important in here. It's not user, it's not customer, it's everyone that is interested somehow in the success or in the failure of the system that is going to be a stakeholder. It's about finding the requirements and all the sources and linking them together. Traceability is key when working with a requirement. We will be focusing on that on today's webinar for validation, and in future webinar, when we start talking about requirements management activities, we will be talking about traceability a lot. We have seen different techniques for gathering the requirements: interviews, brainstorming, prototyping, previews, different point of views, questionnaires, and so on and so on. Okay. After that, we focus in a different webinar in the requirements analysis, which is about understanding and negotiating the requirement. Okay. Usually, we recommend doing that by means of models. Okay, models are a good tool for just ensuring that you are understanding properly the requirement, that you are understanding what the user is asking for. Okay, so basically, the analysis is important for ensuring that we are going to specify match the stakeholder needs. Okay, and in the last webinar, we also focus about the specification activity, or sometimes it's said documentation, it's the same, which is about writing the requirements. When we have properly understood the requirement, we are ready for writing them. Okay, as important as understanding then, it's also that everyone that reads the requirement understands the same thing. Okay. We have mentioned that there are patterns for writing the requirements in themselves, something like the system shall, wherever, always using the same pattern, be consistent when writing the requirement, and also patterns for the document, for the specification document. Okay, we have also mentioned about the IEEE pattern, okay, with different section in the document. When specifying the requirements, we have also mentioned some techniques, some rules that we should follow, or at least we should try to follow for writing them. The requirement must be clear, unambiguous, verifiable, feasible, design-free, complete, and so on and so on. also some rules for the, not for the single requirements, but for the whole specification. We have already mentioned about them. We will be talking a bit more about them on today's webinar, because they are for the specification. Those rules are for the specification, but we will be taking them into account also during the validation. As I mentioned before, at the end, all the 4 activities are mixed together. We are just using some techniques that are common for several activities. Okay, I don't want to mention that yet, but as we will be watching and will be discussing on today's webinar, for example, prototyping is a technique for gathering requirement, but it's also a technique for validating requirement. Okay, so the same goes for those rules. And the important thing here in the requirement specification is that remember that the requirements are written once, but we are going to read them thousands of times. So let's spend some time writing them properly. Okay, so that's basically what we have covered on previous webinars in the series, which lead us to today's webinar, which is going to be the last activity in the requirements engineering process, and that is going to be the requirements validation. That is going to be the topic for today's webinar. So let's start with the new content, with today's content, which is going to be all about the requirements validation. For those that are used to work with requirements, you will feel familiar with some of this sentencing here. But when you just finish the developing, finish with the test, and you just are ready for deploying the product, or just in production or whatever, when you just face the customer, you discover things like that the product, it's a system or it's software, it works. Okay, you have run all the tests are fine, it's going to comply with all the tests, so it works, but suddenly it's useless. Okay, the customer said, okay, it's fine, it's worked, but this is not what I asked for, or you forget to put that in here, or it's fine, but I'm missing these things. Okay, so requirements can be perfectly well documented and specified and also verified by means of tests, but at the end they are going to be completely useless, because when we deliver the product, it's going to be system, it's going to be a software, the customer is not going to be satisfied with it, because it's not going to be what he asked for. Okay, in this point is when I would like to distinguish between 2 important concepts when talking about validation, because we are always missing them together and they are not exactly the same, which are going to be validation and verification. Okay, verification, and this is going to be a perfect sentence for understanding those 2 concepts. Verification aims to answer the question, is the system being built right? So basically just, I don't know, I'm just building a software, and in order to verify that software, what I'm going to do is just run some tests and check that the system, it's working properly. Okay, so when I click in here, it's going to work, it's not going to crash, it's not going to freeze, it's not going to whatever. So everything seems to work, everything seems to be fine. That's verification. Okay, just test everything in order to verify that the system is being built right, that we have built the system right. Okay, the validation, and that's going to be what we are going to be focusing on today's webinar, it's that aims to answer the question, is the right system being built? Okay, because we can build the system right, but at the end discover that the system that we have built is not the right one, it's not the one that the customer asked for. Okay, so those 2 concepts are usually mixed together, but they are not exactly the same. Okay, it's important to just distinguish those 2, because one is super close to the requirements, which is the validation. The validation is basically to somehow verify, somehow validate that we are producing the system that the user wants. Okay, and the verification aims to just verify that the system is working fine, but whatever it's the system that the user asked for or not. Okay. There is also a definition in here that I have gathered from the Babok guide. Babok is just the business analyst body of knowledge. Okay, and that told us that the validation ensures that all the requirements support the delivery of value to the business, fulfill its goals and objectives, and meet a stakeholder need. Okay, so that's a more proper and more formal definition for validation, for requirements validation. Okay, once again, in a different body of knowledge now, instead of the BABOK, which is the business analyst body of knowledge, in the PMBOK, which is the product manager body of knowledge, there is also a couple of definitions for those two concepts, the validation and verification. Okay, validation, it's the assurance that the product, service, or system meets the needs of the customer and the other identified stakeholder. Okay, that's the important part. It often involves acceptance and treatability with external customers. Contrast with verification. And the verification, on the other hand, is the evaluation of whether or not a product, service, or system complies with a regulation, requirement, specification, or imposed condition. Okay, it is often an internal process and contrasts with validation. Okay, basically, verification is just check that the system that we have developed match with the specification, match with the requirements, match with the regulations. Okay, that's verification. But checking that that specification, that those requirements, that regulation match what with the customer or with stakeholder, that's the validation. Okay, so that's the main difference between those two concepts. Usually it's difficult to understand, and also by reading the description, it's even more difficult sometimes because they are not so clearly pointing to those two different concepts. But it's important to take those in mind and just be sure that we are not just verifying but also validating. Okay, because sometimes when we talk about validation, the people usually think about test. Okay, that's quality assurance, that testing. I test the system works, so that's fine. Well, yes, but no, it's not enough. You have to test it, but you have to also get the approval for the customer, and that's related with the validation and with the verification. Okay, that's what we are going to be focusing on today's webinar, validation. Even though those two concepts are usually mixed together, sometimes a requirement that is not well written, not well formed, an ambiguous one, for example, is cannot be verified and also cannot be validated. Okay, so those two concepts once again are really they usually comes together. So now that we know exactly what is validation and we can distinguish that from the verification, why it's so important to validate? Well, we can check that in those two graphs in here. Well, before discussing the graphs, I would like to apologize because I usually don't like to add any graph without a source. Okay, but I have been looking over the internet. I have found some graphs about the importance of requirements validation, but this is probably the most graphical one I have found. I don't have a source, an official source for this one, so sorry for that. But if you Google requirements validation and check that, you will get with some of those graphs also with proper authorized source. Okay. Anyway, as you can see in here, if in these charts, in these two graphs, we can just check the effort against the time in this scale. So basically, if we don't validate during the requirements engineering, we will finish with the requirements. We will have requirements finish earlier with less effort. Okay, but at the end, the testing and the deployment of the system is going to be much more expensive, much more. It will require much more effort because we didn't validate at the beginning, and we will be discovering things that are not right at the end of the cycle instead of discovering that at the beginning. Okay, so if we validate, we will spend some extra time with the requirements, but at the end we will save time because the testing and the deployment at the end of the step, we don't have to go back to design because this is not what the customer asked for or whatever. So that's why it's so important to validate. We spend some extra time at the beginning, but at the end we will finish saving a lot of time. Okay. Then when I have to validate during which activity of the requirement process? Well, and once again, as I mentioned before, those 4 activities in the requirements engineering, including the validation, are linked together, are usually mixed together. So we can once again go back to the BABOK, the business analyst body of knowledge, to get a proper time frame for validating. Requirement validation is an ongoing process. Okay, important thing is ongoing process to ensure that stakeholder solution and transition requirements align to the business requirement. So this means that we have to validate at every stage during the requirement process, okay, in a more formal way during all the activities, okay. So we have to validate during the elicitation, when we are gathering requirement, when we are just capturing the requirements with the stakeholder, with the different users, we have to check back, we have to get feedback from them. So checking that we are properly understand what they are asking for. When they explain something about the system they want, we have to just get some checking for them. Okay, so what you are saying is that you want to do is what you want to do is this, or the system you need is going to do this or do that. Yes, that's right. Or no, it's not right. So we are validating when we are gathering the requirements. We are validating also when analyzing the requirements. Okay, we're checking that the domain description and the requirements are correct by means of models. Again, we usually just recommend doing models for the validation, for the analysis. So those models can be also validated with the stakeholders if they understand the modeling notation, the modeling technique. That will be super helpful. And by validating those models, we are again validating during the analysis. And also during the specification, when we are writing the proper documents, we have to check that the defined system requirements will meet the user requirements. So the low-level requirement meet with the high-level requirement assumption. We have to check the conformity of the rules, of standards, and so on and so on. So basically, the validation is going to happen not at the end of the requirement step, but during the whole requirement process. Okay, as I mentioned before, the 4 activities, not stages, are going to be mixed together. So we are going to validate during the whole time. So which validation techniques or which validation techniques we suggest, we recommend for just ensuring that what we are going to build is the right system, is going to fit the user needs? Well, there are different techniques, different mechanisms that we can use. We have gathered here in here 5-1. Probably there are more of them, but I think that these are a good set of techniques for start, which are going to be simple checks, okay, different checks that we can perform to just ensure that the requirements are fitting the needs, checking traceability of those requirements, checking that the requirements are written in a proper way, things like that. I will be explaining that afterward. Prototyping, which is a really valuable technique when validating the requirement. We have mentioned prototyping during the elicitation, but once again, it's going to be really helpful, super helpful during the validation. Functional test design. Okay, we will be mentioning how we can write down tests in order to validate the requirement. Not that the tests are going to validate the requirements, they are going to verify those requirements, but by writing those tests, we are going to validate the requirements also. Okay. Reviews, perform some formal reviews to the requirements specification, to the requirements document in order to validate them. And finally, by means of models. Okay, so those are the 5 techniques. We are going to be focusing on the 4th one. I'm going to skip the models because we have already mentioned about models, about modeling, and I don't want to spend too much time talking about models because that will require a completely separate webinar for that. So just focus on the first 4 techniques. Okay. And the first one, it's about checks. Okay, so there are various checks that can be done when performing the validation. Using traceability techniques, for example, as I mentioned before, is a really valuable technique, a really valuable check. Okay, so for example, given the requirements document, verify with the elicitation notes that we gather during the elicitation session that all those notes are covered by means of the requirements. Okay. Also, checking traceability between different level of requirement. For example, we may have a user requirement, which are the high-level requirement, and system requirement, the low-level requirement. We have to check, we have to validate that every single system requirement is coming from a authorized source, usually a high-level requirement, a user requirement. Not necessarily all of them must come from them, but we have to check that traceability. We have to check that all the user requirements are being covered by low-level requirement, things like that. So traceability is really important in here. Okay. That involves developing a traceability matrix. Usually, that is a really popular or a really graphical technique for highlighting those traces. Okay, and we can ensure that all the requirements are being taken into consideration, and everything in the specification is justified. Okay. For creating the traceability matrix, well, we can do that in Excel. That could be a good starting point. But at the end, when we have 1,000 of requirement of user requirement and 1,000 of system requirement, that is going to be really difficult to handle. So, and I'm going to just make a first point in here. For traceability, this is going to be one of the points in the requirements engineering process where a tool is going to be really handy. Okay, a requirements tool is going to be really helpful. I don't want to explain that yet. We will be talking about that into a future webinar, but it's important to understand that a requirements tool is going to really helpful. It's going to be really helpful during different part of the requirements engineering process, and traceability is, of course, one of them. We have also to, by means of these checks, not just check that everything is traced, which is, of course, important, but also check that the requirements are well written. Okay, we mentioned during the specification chapter that the requirement must be clear, atomic, unambiguous, and in fact, there are some people that describe these rules for writing requirement as a validation technique instead of as a technique for writing the requirement. Well, it's the same. I mean, we have to take them into account when writing the requirement, and at the end we have to take them also into account just to verify that the requirement that you have written are following those rules. Okay, so by ensuring that the requirements that we have written are, for example, unambiguous, we are going to ensuring that those requirements are easier to validate. Okay, because something like I don't know, the system should be user-friendly, that cannot be verified and that cannot be validated also either. Okay, so take those things into account. Another really valuable technique for validating are the prototypes. Okay, it's excellent for validating with the users and customer. Okay, basically, as we mentioned during the requirements elicitation webinar, the prototyping is just a technique in which you just build a prototype. You just build a simulation of the system that you will be building. If it's a software or a system, doesn't matter, but you just build this small or big prototype that represent the part of the reality or part of the system that you will be developing. So you can present that to the stakeholder, to the users, and get their feedback. Okay, it's usually prototypes are, well, not usually, always prototypes are more accessible than specifications, and it's really helpful to demonstrate the requirement to the stakeholder and help them to discover problems. Okay, for example, for a software, if we are developing a software, we can just create some prototypes of different screens or of the different interaction that the system is going to have with the user. And even if there is no logic behind that, because there is nothing yet being developed, the user can just, we can just simulate with the user, okay, so this is how it's going to work. You will be doing this, you will request this, and the system is going to answer that, things like that. So by means of that, the user is going to easily just tell us, okay, so yes, this is what I want, or no, you are forgetting this in here, or we are missing some interaction in there, whatever. So prototypes are super helpful for gathering requirements and for validating that the requirements that we have gathered are fitting the user needs, okay? Just as we mentioned, I don't want to repeat myself. So just as we mentioned during the elicitation webinar, there are different prototyping techniques. The paper prototypes just basically use a paper for writing whatever, design the user interface and just simulate with the user what it's going to do. That's going to be one of them. Wizard of prototypes, in which one person, the wizard, is going to be simulate that he's the system and is going to simulate the answer that the system is going to give to the user. And finally, the automatic prototypes, which are going to be the king of the prototypes. Basically, just it's going to be a simulation of what the system is going to do. The user is going to, or the stakeholders are going to interact with a not yet developed system, but they will just work with it as is the final system, and we can get really, really important feedback from there. Okay. Another validation technique, a really important one, is the test design. Okay. Once again, test design, no testing yet. Okay, that is going to be at the end of the development. But by designing the test, by writing down the test plan, we will be validating the requirements. Okay. For example, the functional test of this of the system must be developed sooner or later. We can develop then when the system is finished. Yeah, why not? But we strongly recommend writing those even while we are writing the requirements. Okay, they should be derived from the requirement specification. Each functional requirement must be associated at least to one test. The non-functional ones are going to be more difficult to test. Not all of them, but something like really reliability or exclusive requirements. Okay, those are going to be more difficult. And as I mentioned, each requirement test case must be traced to its requirement. Okay, so by designing this test, we may reveal errors in the specification even before designing and building the system. Okay, so the same goes for the use cases. Okay, when writing the test or when writing the use cases, we are going to write an scenario, just an interaction between the users and the system. Okay, the way we are going to test this is by, okay, the user is going to ask this and the system will answer that. If that's not the answer, then it's not working. But when we write the test, we are just writing the scenario, and by writing the scenario, we will discover if we are missing requirement, if some requirements are not well written, if some requirements are not if we are not writing the proper requirements. We are validating the requirements by writing those tests. Okay, so that's why writing the test specification, when we are writing also the requirement specification, it's really helpful for validating. Okay. In fact, some software development process, specifically, for example, the agile methodologies, begin with tests even before programming. That's what we call the test-driven development. Okay, so that's something that we must take into account, that writing the test specification is going to help us to validate the requirement specification. And finally, remember that I'm not going to be talking about models today. The last technique that I'm going to be discussing is the requirements reviews. Okay, and what's a requirement review? Well, basically a group of people read and analyze the requirement, look for potential problems, meet to discuss the problems, and agree on a list of actions items needed to address those problems. Okay, I was reading in a business analyst blog some days ago that this is probably something that is not likable, that people usually don't like, because it basically consists of just gather everyone into a room, all the stakeholder, or at least one represent for each stakeholder, and just review the requirement specification. That is super boring, but it's something that must be done. Okay, no one said that it's going to be fun. It's something that we must do in order to ensure that we are writing the proper requirement specification. Okay, so take that into account. It's boring, but it's helpful. It has to be done. Someone must do that. Okay. So basically, it's a meeting where you gather all of your stakeholders together and walk through the requirement documentation page by page, line by line, to ensure that the document represents everyone's complete understanding of what is to be accomplished in this particular project. As simple as that, as boring as that. Okay, take into account it's not going to be super fun, but it must be done. Okay. Of course, there's different type of reviews depending, of course, on the degrees of formality. We can just read in the document, or a person different than the author of the document, just peer reviews, for example. It's going to be, another one could be reading and approval, because there will be a sign in the document. So just encourage the reader to be more careful, because it's going to accept or reject that document. We can go through walkthroughs, which are more informal, high level, and things like that. Okay, and formal inspection are usually just very structured and detailed review, when the roles of the participant are going to be defined, are going to be more precise. Okay. As an example of a requirement review technique, we can just go to the IEEE 1020H, which is a standard for software reviews and audits. Okay, that one is going to be for software. There's going to be a different one for system, but it's going to be pretty close one. Okay, so one of those sessions in which we are going to gather with the different stakeholder what we must do. Okay, well, in order to facilitate the session, we have to set the stage, set the place where we are going to gather. We have to be prepared, reading the document first, just write down any question, any doubt that may arise at the end, be prepared. Okay. After that, we just gather everyone and we lead the walkthrough section by section, just reading the different section, the different requirements. Usually it's not recommended to go requirement by requirement. Okay, it's something that can be done. It's proven to be helpful, but there are some arguments, there are some things to say against that, because it make it very difficult to follow the session. So sometimes it's not recommended to go requirement by requirement. We have to set up checklist, common problems, and guide reviewers. We will be mentioning some checklists in the next slide. And also ask for a sign off at the end of the session. So everyone is just saying that I agree with this. Okay. Issues when reviewing the requirements. Well, doing the requirements walkthrough too early, when the specification is not yet finished, with all the requirements are not yet well written. So maybe it's not the best moment. We shouldn't be reviewing the requirements, let's say every day or every week. Okay, so let's wait for the specification to be at a given state. As I mentioned, reading every requirement aloud, it's going to make the session more difficult to follow, because it's going to be a huge session just with the system shall, and it's going to be more difficult to just contextualize. So let's try to focus on features, let's try to focus on functionalities and things like that, and just analyze and be sure that everything is covered. Not including the right people into the meeting, forget someone that must verify something, validate something, sorry, it's super important. No one says a word, You start reading the requirement, everyone's agree, and no one says something. Well, that's probably an error. It's like the same goes for testing. When you just run your test and nothing is wrong, probably you're doing something wrong with the test instead of that the system is perfect. Okay. Or also, this is important that we try to avoid this, that the review session turns into a design meeting. We are not designing anything. We must not go to the how. We must not go to the solution design yet. Okay, that's outside the requirement. So let's try to not go there too early. Not go there too early. Okay. And this is an example of a checklist that is recommended to run during the requirement specification reviews. Okay, it's been gathered from the CAD viewers work. Okay, it's copyrighted in 2001, but still valid. And as you can see, there are different sections for this. Just organization and completeness, correctness, quality attributes, traceability, special issues that we must analyze, and we must check that we have followed during the meeting. So, are all the internal cross-reference to other requirements correct? Just analyzing traceability. Do the requirements conflict with or duplicate other requirements? We have to go checking that no requirement is going to be in conflict with no other single requirement, and so on and so on. Okay, just an example of a checklist for the requirement specification review. Okay, and basically that's all what I wanted to say about requirements validation. Of course, there is much more. We can go much more in detail in all the process, in all the requirement validation activity, but I think that's enough for today. Just 50 minutes. I have been asked to try to keep it lower than an hour, taking also into account the question and answer session, and I think that I have been successful into that. So yes, let's try to summarize what we have learned today about requirements validation, about the requirement validation activity. So first of all, we have we have focused on distinguishing validation and verification. Often they are together as V&V, validation and verification, but they are not the same. Okay, requirements verification. Always remember this sentence: is the system being built right? Okay, it's usually linked with test. Requirements validation: is the right system being built? Okay, so they can seem close, but they are not the same. Remember that. Okay, remember that it's not enough when building the system right. You have to build the right system. Another thing that we have learned today is that the requirement validation is an ongoing process. It will happen at the end of the requirement process, yes, of course, but also in every other stage. Okay, we will be validating when gathering requirement, when analyzing requirement, when specifying requirement, and at the end of the specification, we are going to perform some reviews of that specification. So we are going to validate again. So we are going to be validating during the whole requirements engineering process. Okay, there are several validation techniques. We have seen five of them, like simple checks, include traceability and well-writing requirement, prototyping, functional test design, but also if we are doing use cases, a use case design also help us to validate, reviews, models, and so on and so on. Okay, just to mention some of them. And remember that always traceability is key for validation, not only for validation itself, just to validate the elements, but if we discover some conflict, something that is not valid, sorry. For example, okay, this requirement is not matching with this other requirement for this other user. Then the traceability to the source of the requirement is going to be important in order to look for the stakeholder that requested that requirement in order to try to fulfill that conflict, for example. So traceability is key for requirements validation and for requirements engineering. Okay. And that's basically all for today. Okay. I have been as I mentioned before, recording this this session, this webinar, and we will be uploading that to the corresponding channels afterward. But what I'm going to do now is just to stop the recording, and we will be moving forward to the question and answer section. So for those that are watching us in a video over the internet, just thank you for your attention, and hope to see you in a future session of this webinar. The next session will be probably, it's not yet announced, but it's going to be in January the 20th. Yeah, I think so. The 20th. It's Wednesday, if I remember well, and it's the 20th, and it's going to be focusing on requirements management, traceability, versioning, and all those activities that are going to, or those tasks that are going to help us to cover the whole requirement engineering process. Okay, so for all that are watching us, as I was saying, in a video channel, thank you for your attention, and I'm going to now move forward to the question and answer section.